Okay. And so what we've got going on today is we're balancing equations. So you do hopefully see that little assignment. I did open it up finally at 9 o'clock this morning. But under Wednesday, I gave you a new Jamboard link. So, and I'm sorry that I'm kind of killing this whole Jamboard thing, and you guys are probably like, no more. But I do think that it's helping a little bit because at least you can take the notes with you. And if you kind of were checking back throughout the day yesterday, I do have to delete it so that I have something for my other classes. But what I did for today's is I'll put all the notes at the end of the whole Jamboard. Okay, and that way you'll be able to use that. There. So if you'd like to go ahead and join the Jamboard, you can do that. That's that first link. And then these two videos are in this bottom one is in the actual assignment today. This top one is if you need a little bit more than what I'm giving you in the Zoom call today. Otherwise, the Zoom call should cover it. So that's my idea. And then you have your little exit ticket. So I'm going to go over to the Jamboard. I'm going to get us started. That way I'm not keeping you overly too long. So on slide 1, you get to start on slide 1, which is awesome. So if you are following along on Zoom call, I would make sure you are watching because today is a complicated topic. And if you're going to join me on the Jamboard, please do. I only see a couple. So I recommend it. Anyway, what we see on this first slide right here is you have basically what has been covered now for the last couple days. The parts of your equation, we have our reactants, we have our products. It's going to be important to always be able to find this yield sign right here because this yield sign is kind of like your equal sign. And you're going to be looking at it as like this side has to be equal to that side, right? We saw that yesterday, that conservation of mass is super important, right? And yesterday, you really enjoyed just the simple subtraction and addition and things like that. And today, now it's going to get a little bit more into multiplication, okay? Only if you use a certain method, but I'll kind of walk you through that in a second, okay? We're going to be forming something called a mole ratio that you kind of see right here, okay? So we're going to be doing a mole ratio. A mole ratio is going to be talking about those coefficients, okay? So just a reminder, let me get yellow. There we go. This little 2, that is your subscript, right? Subscripts come straight from the formula, right? They only apply for the thing right in front of it. When you have, and then we're going to see in today's example that if we have H2O, okay, that little 2 only applies for that, right? If we had something, we're going to see that another way to write your H2O is going to be H and then put in parentheses OH. And I'm going to show you why on a certain example. So keep your polyatomics together. If we had something that said OH with a little 2 on the outside, H2O2, so this is hydrogen peroxide. But if we have that, remember that little subscript applies for everybody on the inside. Today, your goal is messing with those coefficients. You're going to be adding those in, and you're going to be telling me what are the coefficients that you're putting in order to conserve mass, all right? So I'm going to go ahead and go to slide 2. All right, so right here, I'm going to zoom in on this for my people who are watching from the Zoom screen. Okay, so mass is not being conserved. All right, so when we were writing these little equations, I did not mean to cross that out. There we go. But when we were looking at these equations, you know, we're like, we kind of focus on those numbers, but not really, right? So this little image that we have here is showing you really what we're looking at. So if I have aluminum, there's nothing in front of it, nothing behind it. That means we have 1, right? So that means that we had 1 aluminum atom, okay? Here we had a little 2. That 2 applies to that, which means I had 2 bromines. So there's 2. Over here, we're now seeing that we still have that 1 aluminum, but now we have 3 bromines. And you can see that in this picture. Well, 2 and 3 are not the same number, meaning 1 plus 2 does not equal what we have over here, which is 4. Mass is not conserved. The number of atoms is not conserved. And so that's what you're fixing today by adding in these coefficients. So what we're looking at here, where it is showing you that mass is conserved, is you're now saying, okay, well, we recognize that bromine was off, right? We had 2 versus 3. So a common factor of both of those is 6, right? So in order to get both of them to 6, we're going to triple this guy. So we drew it 3 times in order to have 6 bromine atoms. And over here, I'm going to go ahead and double this so that now I have 1, 2, 3, 4, 5, 6, right? So we have our 6 bromine atoms. But now we just made it to where we had 2 aluminum atoms. So we had to add another aluminum atom in order to get the 2. So what you saw form up in the actual equation is we added in those coefficients, okay? And this image thing that I'm showing you right here is kind of the one that I'm recommending you use, all right? I'm going to show you 2 methods. So if you're still with me on the Jamboard, go ahead and go to slide 3. All right, so I'm going to show you this box method thing, okay? And so big idea is that we're going to draw this line right here, meaning everything, my reactants have to equal my products, right? So with the box method, and I'm going to kind of refer back to, if you remember the other day when you had that magnesium phosphate thing, the reason we're doing the box method is because it gets overwhelming trying to say, okay, I have 3 of these, I have 4 of those, but nope, just kidding. I have 8 of those, and I have 2 of these. And if I put a 3 here, then that means that now I have 9 and so on and so forth, right? We saw that got complicated. So that's why we're putting our focus on this box method. Remember, I told you yesterday, images are going to kind of help your brain grasp this just a little bit better. Sorry, I'm trying to erase stuff. Okay. All right. So let me make it to where I have a highlighter. That'll be a little bit easier for you guys to see. Okay. So what we have is aluminum 2, oxygen 3. So what that means is this 2 goes there, that 3 applies to there. So when you go to draw this out, it means that you have 2 aluminums and you have 3 oxygens. You're going to put that into a box. The reason we put that into a box is because you can't just split those up, right? I can't just add another aluminum because I need another aluminum or so on and so forth, right? So you have to leave things in the box, and that's why we're drawing the box around them. So if you need to add another one, you got to add a whole box, which means you need to add all the oxygens, all the aluminums, right? Okay, on the product side, we see that we have 1 aluminum, and that's it. That's its chemical formula. That's all that it exists as. Then we have this little diatomic oxygen, which means we have 2 oxygens. Okay. So looking at these 2 pictures, we see that, well, the aluminums aren't matching up and the oxygens aren't matching up, right? So we can say, okay, well, I have 2 aluminum. So let me draw in another aluminum, right? So now I have 2, I have 2. Over here, I'm going to look at my oxygens, and I have 3 on this side. Let me change my color. So I have 3 oxygens on this side, but only 2 on this side. So just like we saw in the last thing, 2 and 3 is a nice ratio because 2 and 3 tells me that I can go to 6, right? We can say 6, okay? All right, so when we have that situation, then we're going to say, okay, well, if I need to get 6 oxygens, then I'm going to add in another box with my 2 aluminums and my 3 oxygens. All right, so I have 6 oxygens here, and then I'm going to come over to this side. I'm going to say, okay, well, I need to have 6 oxygens over on this side. So now I have my 6 oxygens, I have 2 aluminums, but I have 4 on this side. Uh-oh. So all that means is we're going to come back over to my aluminums. I'm going to do this in another color so you can kind of start seeing the steps when you come back to this slide later. So we're going to say aluminum, aluminum. And now I have my 4 aluminums, everything is balanced. So your last and final step, especially on today's assignment, is that you're going to basically count up the boxes, right? So we have, oh, you know what I just realized? I'm so sorry, y'all. I will share the link in the chat. I know some of you guys actually were relying on that, and I'm so sorry I didn't think of that earlier. So if you want to join us on the little Jamboard, you can do that now. I'm sorry. It is on your Schoology page. It's up at the top. But just in case you missed that, there you go. All right. So what we have is there we go. So if we were to count this up, we have 2 boxes of this molecule right here. So we're going to put a 2 right here in the front. Okay. Over here, I have 1, 2, 3, 4. So I'm going to put a 4 in front of my aluminum. For the oxygens, I have 1, 2, 3 boxes. So I'm going to put a 3 right here. Okay. So that is that's what you're doing with the box method, is basically you're making your pictures match up. So you're making these pictures match up to these pictures, only adding boxes with the appropriate number of atoms that are in each box. And then at the very, very end, you are counting up the boxes, and that's it. Okay. So box method gets shown to you, I believe, right at the beginning at like question 2 or 3. So with that, I kind of walk you through the steps, but if you're watching this, you'll be fine. All right, so I'm going to go to slide 4. So if you're just joining us, I do see a couple that showed up, sorry. Go to slide 4. We're going to look at this one. I'm going to do box method one more time to kind of give you that visualization. Okay, I'm going to draw a squiggly down the middle. So again, we're on slide 4. Okay, now I'm going to go ahead and draw my molecules in. So I have KClO3. So remember that 3 goes only to the oxygen. So that means that I have 1 K, I have 1 Cl, and I have 3 oxygens. And I'm going to put all of those into a box. On this side, I have 1 K, 1 Cl. And I'm going to put those guys into a box because that is the molecule right here. And then finally, I have a diatomic oxygen. So I'm going to go ahead and put those into a box. You notice that I put the oxygens vertical, and then these guys are horizontal. I kind of put the different elements horizontally and then the same ones vertically, or I kind of put them together so it's easier to count, but you do what works for you, okay, as long as they're in a box. All right, so now that we have that, we kind of say, okay, well, K looks okay because we have one over here, one over here. I have 1 Cl, 1 Cl. Cool. But then I have that 3 and 2 again. So remember, we're trying to get to the number 6 for those. So we're going to go ahead and add in another box on this side. On the reactant side. So I now have my 6 oxygens over here, but now I also have 2 and 2, right? So I'm going to go ahead and say, okay, well, let me take care of this. I'm going to say KCl. Okay, so now I have my 2 and 2. And then finally, I'm going to come over and fix my oxygens on this side. So I have 1, 2, put them in a box. 1, 2, put them in a box. Okay, so I now have 2, 2, 6, 2, 2, 6. Everything matches up. So last step, once again, is you go through and you count. You say, I have 1, 2. So I'm going to put a 2 in front of that first one. Here I have 1, 2. 2 in front of the next one. 1, 2, 3. So a 3 in front of that oxygen. So your mole ratio here, mole ratio just means your coefficients, is going to be a 2 to 2 to 3. Okay, and I'll kind of be using the word mole ratio again tomorrow to kind of help. Okay, so that is box method. The other thing that gets shown to you at the end, and you do not have to use it, but if you absolutely hate box method and you're like, oh my gosh, Miss Fogel, why are you making me draw a bunch of stuff? Okay, you can go ahead and go to slide 5. It'll be the same problem, but I'm going to show you how this one works. So here, you can do the line down the middle. All right, in the last question, you have a choice to show me which one you want to show me. You can do either one. Okay, but what you've got here is if we put this line down the middle, you're going to list out what elements individually you have. So I have a potassium, I have a chlorine, and I have an oxygen. Notice that they are the same elements on both sides. Okay, so what you do now is you have to count them up. So how many Ks do I have on my reactant side? I see 1. So we're going to put a 1 there. How many do I have on my product side? A 1. The chlorines on my reactant side is a 1. Chlorines on my product side is also going to be a 1. And then my oxygens on my reactant side is going to be a 3. Oxygens on my product side is going to be a 2. So the next step when you're doing this method is you find which ones don't match up. So we have a 1 to 1, 1 to 1, and then we have this 3 to 2, right? And so once again, we know in our heads, oh, we got to get to 6. Well, we know that this one multiplied by 3 gives me 6. So we're going to put a 3 right here, right? So this is where that distributing thing. So if you hated that whole first idea with the magnesium phosphate, you want to stick with the drawing thing. All right. But anyway, so we put a 3 here and then we recount. So we affected something on this side. So we're going to recount everything. So I still have my 1. I still have my other 1, but now I have 3 times 2. 3 times 2, you multiply. That makes this now a 6. So then we're going to go back to our reactant side over here, okay? And we need to fix this. So we know in order to get 6, we have to double this. So we're going to put a 2 right here, okay? And we're going to do a recount, right? So now we're going to do our recount. I should have done that in a different color. I'm sorry. There you go. So we have our recount. We go, all right, now I have 2 potassiums. I have 2 chlorines, and I have 6 oxygens. So now we see that our potassium and our chlorines aren't balanced. So our last step is we're going to go back to our potassium chloride. So we see that we have these 2 guys that are going to get affected. We're going to throw a 2 in front of that, and then we're going to recount. So now I have 2 potassiums, 2 chlorines, and now we're actually balanced. Okay? So if you don't like this method, go back to slide 4 and you can see how we did it with the box method. In my opinion, box method is a lot easier to grasp than trying to sit here and figure out who's multiplying by who. Okay, but everyone's different. So you pick which method works for you, and it's important to practice. So the last thing that I'm going to kind of go over, and I know that I'm going a little over my